Hey, let's solve this question together. This question is the follow-up question of the famous LeetCode named toSum. I would advise you to watch my previous two videos about how to solve toSum and toSum2 because I will be referring to it for the explanation and for the solution. Let's read the question together. Given an integer array nums, return all the triplets num I, j, k such that blah blah all different and that the sum is equal to 0. Notice that the solution set must not contain duplicates triplets. Okay. As always, let's make sure we understand the problem by reading the examples. So example 1. Nums equal -1, 0, 1, 2, -1, 4, -4. So first we can see that we can have a duplicate, right? That's good to know. Output -1, blah blah. Okay. So the reason we have this is because -1 plus -1 plus 2 equals 0, as well as -1 plus 0 plus 1 equals 0. What is interesting is to note that, as they say here, must not contain duplicates triplets. We have -1, 0, and 1, but we don't have 0, 1, -1 for this reason. Okay, example 2. There is no solution. Okay, example 3. This is the only solution. Okay, sounds good. We will talk about two solutions. The first one will be a brute force approach, and the second one will be more efficient. Let's start with the first one. If we want a combination of three numbers in an array, the brute force way of doing that is just by doing 3 for loops, as you can see here, I, j, k. But the complexity is O of n cube, and we can do better than that. So let's go to the more efficient solution. And that's where I advise to watch my previous two videos about toSum and toSum2. Now that you have in mind how to solve toSum and toSum2, we are tempted to do the same. We could, for example, do a for loop over nums and then try to find toSum with the opposite of our current number. So for example, for this one, we would try to find toSum in this array with like target equal 1. So if we find target equal 1, for example this one, we have -1 plus 0 plus 1 equals 0, and it works. The issue with this solution is that we will find, for example, this solution, which goes to 0, so it's fine, but we'll also find 0, 1, and -1. And that's not what we want because we are not allowed to have duplicates. One way of solving this problem is to sort nums. Now that we have a sorted array, we can see that it's easier to find duplicates because duplicates will be next to each other. So if we have -1 here, for example, for this solution, we can see that we can skip all the -1s because they will be next to each other. So what we want to do is to find a way to skip them if the same number is next to the previous one. So for example, when we are in our for loop and we are at -1, if we check that the neighbor is also -1, we can just skip it and start with this one, and then we will find, -1, 0, 1. And this is one way to avoid duplicates. Now let's solve the problem. So we will have one for loop going over nums. So let's say, it starts with this one. Then we will apply toSum for this array. And if you remember toSum from the previous video, it works with 2 pointers, left and right. And then based on the sum, if it's bigger or smaller than the target, we will move the pointers inside. Right will be moved to the left, or the left pointer will be moved to the right. So basically, what we need to do is to really understand how to sum as well as to sum 2 works, because it will be very helpful. And 3sum is basically to sum 2 with 1 addition is to avoid the duplicates. And to avoid the duplicates, it's basically we look at the neighbors, and as long as it's the same, we skip them. Let's see it with the code. Okay, let's solve this problem. So we said that we are starting by sorting the array because that will help us to find the duplicates. We'll talk about the complexity later, but already this is n log n. Then we'll have an array for the result, and now we can start our main for loop. So for we will work with 3 pointers. The main one, which will be like left, and then middle and right. So for left in range len of nums. So we said that as long as the value is the same as the one just before, then we skip. So a way to check it is if left is more than 0 and nums of left minus 1 is equal to nums of left, then we just continue to the next execution of the for loop. So we said we need 3 pointers, left, middle, and right. So middle and right, so middle will be equal to left plus 1, and right will be equal to len of nums minus 1. While middle is less than right, and then we can check our sum. So the sum is nums of left plus nums of middle plus nums of right. So now we can check the main conditions. So if the sum is less than 0, which is our target, it means that we need to move middle to the right. So we have middle plus 1, else if the sum is more than 0, it means that we need to find smaller. It means that right will take minus 1, else it means that so we found the target. So at this point we can do result dot append. So we want to append our list, which is nums to left, nums to middle, nums to right. We'll need to skip the numbers because it's possible that within the middle and right index we have some duplicates. So we'll need to find a way to also remove the duplicates within the 2 pointers. So what we can do is, while middle is less than right, because we don't want to do that, and while nums of middle is equal to nums of middle plus 1, then we want to increase middle. So with that, we will be able to skip the duplicates even within the 2 pointers that are moving right and left. So we can do the same on the other side. Nums of right minus 1 equal nums of right, and we want to decrease. Okay, and decrease and increase this too. Yeah, so let's see. Let's read again. We sort the array, and then we have the result. We do a for loop over nums. We skip the first if we have duplicates. Then we have our 2 pointers. We compute the sum. If it's less, we move middle. If it's more, we move right. Else, we found something, so we add to the result. And then we skip the middle and the right if they are the same as the neighbors, and we increase the pointers. So let's see, run the code. Perfect, submit. Cool. Okay, so now let's talk about the complexity. We want to talk about the space and the time. So for the space complexity, it actually depends on which library you're using. So it can be either O of 1 or O of n, because you see that we're not using any other, any additional data structure. And for the time, so what we're doing is we are sorting the array, so f n log n, right? And also we are doing the main for loop, here line 5, and then we are doing the 2 pointers, which is another O of n within the for loop, so it would be O of n square. But what that means, because a square is bigger, it will be O of n square. Cool, so I hope you could understand this problem. Knowing 2sum and 2sum2 is super helpful to solve this one. And as a reminder, I will be solving all these 76 questions, which are the most common LeetCode question asked in interviews. See you soon.